This meeting is being recorded.
Okay, so in last lecture, what we have studied, we have started with the unit number 4. Then we have studied the basic principle of sequential circuits. What do you mean by sequential circuits? Then how it differs from the combinational logic circuits. Then we have studied for the SR flip flop, then static latches and register. Now we are going to start with the multiplexer based latches. Okay. Now there are many approaches for constructing latches. Okay, you can go for a simple storage element, right? Using flip flop, it is possible, but with the help of multiplexer also, it is possible. So there are many approaches that you can construct and develop different latches, and one of the very common technique that involves the use of transmission gate and multiplexer. Right now, what is transmission gate, or in other language, what we are calling for a transmission gate? Pass transistor. Right, it is one and the same. So multiplexer using transmission gate or pass transition, pass transistor, it's one of the very common technique to construct the multiplexer based or the latches using multiplexer. So this multiplexer based latches can provide a similar functionality to the SR latch, but has the important added advantage is that the sizing of devices only affects performance and it is not critically to the functionality. Right, means what? Just now in the last lecture we have discussed how you can construct the latch, right, using SR flip flop, and in by using simple inverters also we have studied that cross coupling of the two inverters that also result that can be also um, result into a latch structure or register type structure. But so the similar functionality can be provided using multiplexer also. Okay, but what is important added advantage of that? The sizing of devices only affects performance and it is not critical to the functionality. Okay, so this multiplexer based design had a certain advantage that sizing, right, it affects only the performance but not the critical functionality. So the implementation of static positive and negative latch based on multiplexer is shown in the below figure, this figure. So it's a negative latch, it's a positive latch, right? It's a negative latch, it's a positive latch. So how it works actually? So for a negative latch, when the clock signal is low, we are talking about this. When this negative latch, when the clock signal is low, the input 0 of the multiplexer is selected. When this clock signal is low, the 0 input 0 of the multiplexer is selected and D input is passed to the output. This D input is passed to the output. Now, when the clock signal is high, we are talking about this negative latch. Okay. When the clock signal is high, the input 1 of the multiplexer is selected, which connects to the output of the latch is selected. That means it is a feedback, right? It is a feedback. Now the output D is selected when clock is high and the output is held using feedback when clock is, unless and until clock is low. That means what? See, simple. When clock is 0, this input will pass to the output, and when clock is high or clock is 1, then this output, whatever the output, it is getting feedback to the multiplexer input, that is this 1, and it will get held by that multiplexer. That means for clock 1, this output remains the same or it is latched using this feedback. A transistor level implementation of positive latch based on multiplexer is this. Now when clock is high, now we are talking about the positive latch. For negative latch, what? When clock is low, this output 0, right? It will get selected and it will pass to the output. Sorry, input 0 will get selected and it will pass it to the output when clock is low. And when the clock is high, this 1 will get selected, right? This 1 will get selected, and it is again feedback through the output, or this 1 will get selected. And what is this one? It is a feedback of the output. That means whatever the output it has passed, it will held that same status unless and until again the clock changes. Exactly reverse is the So Prajakta, where network was disturbed?
So, last 20 minutes, sir.
Last 20 minutes.
Yes, sir.
Okay, fine. We will continue the remaining part in the next lecture.